Hello. Welcome to AP Review number 4, AP Review video number 4. This is the one where we're going to be talking about resources, both renewable and non-renewable. And so this one's going to be kind of similar to the last one in that I'm going to try to focus on problems and solutions, but this one's going to be significantly more informational, just because there's a lot of stuff that they could ask you about resources. There's a lot of information that you should know, and there's a lot of problems and a lot of solutions. So we'll start with non-renewable, and then we'll go into renewable. All right, so now for renewable, or for non-renewable, pardon me, there's basically 4 that you need to know. You need to know natural gas, you need to know coal, you need to know oil, and you need to know nuclear, okay? Now, in order of probably most prominence, oil is probably going to be the first one. So there's crude oil, which is, so crude oil, remember, are hydrocarbons, meaning that it is a combination of hydrogen and carbon. All of these are hydrocarbons. Natural gas, oil, and coal are all hydrocarbons. Okay, it's just how many carbons and how many hydrogens are we talking about? But they're all hydrocarbons. Okay. Oil we extract from the ground in a liquid form. We only get about 35% of it is recoverable. Okay. And remember, the thing with oil is that oil is controlled by OPEC, which is 11 countries that control 80% of the world's oil. And the thing with oil is that because oil was our main source of fuel for such a long time, everything is dependent on oil. Okay. It's the reason why the Middle East is so flush with cash, is because they're flush with oil. So U.S., the world's largest oil user, is also has only 2.9% of the world's proven oil. So we are the largest consumer of oil, and we have the least amount of it. That can be a problem. U.S. oil production peaked in 1974, and about 60% of the oil imports goes through refineries in hurricane-prone areas, which was a big problem this past couple years with hurricanes like Harvey. Okay, so the main problem with oil, especially in the United States, is that we use the most of it and we have the least. Okay, so that's the biggest problem with oil is our reliance on it, and not just America's, the world's, really, because the fact that oil is still used in cars is probably the biggest one, because transportation is the number one user of oil, and all transportation is in some way or shape or form uses oil. So that is by far the biggest problem. What could be the solution for oil? Well, that's the biggest problem. Let's hold off on solutions for a second, because there's other kinds of oil. There's oil shale, which is basically oil in rock form. There's oil sands, which is where you have oil mixed with dirt, and they try to heat the dirt to make the dirt just drop out. And so these are oils basically mixed with rocks, mixed with solids. Now the problems with both of these is that the extraction process for oil sands and for oil shale is bad in and of itself, right? Oil sands requires large amounts of area that you have to strip and clear cut in order to basically make these pools so that you can extract it. Oil shale requires mining and breaking up the rock. Okay, so the extraction process is bad for oil sands and oil shales. Okay, now the benefit, what's the solution, would be to obviously switch from a different source, switch to a different source. Okay, so for transportation, you could switch to electricity. For electricity, like not just like house electricity, we could switch to a different source. So just switching sources is probably the best solution if they ask you about like oil. And then probably the be all for especially like offshore would be oil spills in the ocean. Okay, remember the Exxon Valdez was the biggest oil spill in 1989. It was a tanker that tripped that got split open, and then of course BP in 2010. Is the biggest oil spill on record. Okay. All right. The next one is natural gas. Now remember, natural gas is is in its gaseous form, contrasted to oil, which is in its liquid form. Natural gas is, again, that's not what I wanted to do, is again a hydrocarbon, okay? And remember, natural gas is methane, okay? Methane specifically is methane is CH4, okay? Now, why that's important is because methane is a greenhouse gas, which if we had to know about climate change, this would be a greenhouse gas, which is a very potent type of gas that promotes climate change. That's a really bad 4. I'm going to redraw that 4 because yikes. But if you had to know about climate change, CH4 methane would be a bad greenhouse gas. Now, the nice thing is that of natural gas is that when you burn methane, when you burn it, it is not as potent of a greenhouse gas. So a lot of people say that the natural gas burns cleaner than oil or coal, and that's true. But again, with natural gas, the problem is with the extraction, okay? Because remember, in order to get natural gas, you have to, and that's red, I don't want to do red. Let's do like a nice auburn. There we go. In order to get natural gas, you have to frack, where you dig a hole, you send down just a ton of water into that hole, and you make these little cracks in the ground. And those cracks, when you send all that water down, make these cracks even bigger, and that releases all this gas. So let's do the gas purple. So the gas comes back up, and ideally, you want to capture that gas. And you can capture some of it, but you can't capture all of it. And that gas that leaks into the atmosphere is the bad methane. That's the bad CH4. Okay. So the problem with natural gas is the extraction process and the fact that we are not efficient in catching all of the natural gas. Okay. So 50 to 90% of it is methane. Small amounts of ethane, butane, propane, all of the kinds of gases, but most of it's methane. There's different kinds of natural gas. Natural gas is the primary source of electricity around here, or it's growing to be. We're sort of a mix of oil and natural gas because of West Texas. There's a lot of oil and there's not a lot of natural gas. How do you fix it? Well, the main way that we fix it is to, number one, stop our method of mining it, and remember, this whole process is called fracking. And so the best thing we can do for natural gas is to stop fracking. Okay, or switch from fracking to another extraction method. We could also come up with a more efficient way to extract our natural gas, or the obvious same thing we said for oil is just switch to a totally different source. All right, our next one is coal. Okay, and coal is again, it's a hydrocarbon in solid form. Okay, it's been pressurized and heated and compacted into these bricks of solid rock that you can then burn. And the burning of coal produces a lot of heat, which we then use to generate electricity. Now, remember, we've said this before. I've said this a bunch. Coal is primarily used in the Northeast. Okay, we don't use coal around here because we don't have a lot of coal mines. Most of our coal mines are in the Northeast. Okay, so the main problem with coal is that coal is dirty as hell. Okay, very, very dirty. It is the most abundant fossil fuel we have in the United States, but it is the worst from an air pollution standpoint. It has the most amount of sulfur. It produces the largest amount of CO2, the largest amount of soot, and trace radioactive chemicals. Okay, or radioactive materials. So it is by far the dirtiest of the fossil fuels, and areas that produce a lot of coal, or areas that consume a lot of coal, I should say, are also the ones that are the most prone to air pollution, specifically acid rain. So the biggest problem with coal is that the usage of coal results in the worst type of air pollution and the most amount of acid rain. So there's a couple solutions for this. Number one would be different sort of apparatuses to clean the coal. There's two that you should know. The first one is an electrostatic precipitator. That is not how you spell precipitator. Precipitator. And the other one is a wet scrubber. Now, both of these are contraptions that are put on top of the smokestack or in the smokestack. And essentially what's happens is as the smog comes through the smokestack, the electrostatic, both of these in different ways attempt to remove some of the bad particles from the smog. They'll attempt to reduce the amount of soot, reduce the amount of sulfur. The electrostatic precipitator uses magnets and tries to take advantage of the charge. Man, I am off to a bad spelling start. Oh good Lord. That's magnets. It just says magnets. Okay. Just believe me. It just says magnets. It tries to take advantage of the charge that some of these bad elements have to attempt to essentially cling them and stick them in. Okay. The problem with that is that it turns the waste from a gaseous form to a solid form. And you still have to clean that, and you still have to go somewhere. The wet scrubber basically sprays a liquid chemical to try to cling onto the same chemicals and, again, transfer them from an air form from a gaseous form into a liquid form. So both of these attempt to take these bad chemicals out of the air and turn them into a solid or a liquid, respectively. And that's better than having them in the air, but the problem is it doesn't solve the problem. It just transforms it from an air pollution to either a solid or a liquid pollution. That's one thing you can do. Again, second thing is don't use coal anymore. But sometimes they'll ask a question they'll ask the question like provide a practical solution. And it's not practical to say, yeah, a quarter of America just stop using coal. Would it solve the problem? Sure. Is it practical? Probably not. Even if you say, well, if we switch to a renewable source of energy, then that would solve our problems. Well, yeah, but renewable sources of energy are expensive and they're not easily available, and the technology is really not there. So the key word you want to look for is practical, okay? Because is it a good idea to switch off of coal and oil and natural gas? Hell yeah. Is it practical? Not so much, okay? And then the last one is nuclear power. Okay. Now, the way nuclear power works is you take radioactive material, generally it's uranium, and you put them in these cores, and they produce heat. And you use that heat to heat water, and that creates steam, and you use it to make electricity. Now, the problem with nuclear is that, number one, they're radioactive. They could explode. They produce large amounts of heat, and if they explode, you're releasing a ton of radiation across a large area, depending on how much radiation gets released. That's how you get a Chernobyl. That's how you get a 3 Mile Island. And that's the first problem. The second problem is that because it's non-renewable, it produces waste. It produces namely radioactive waste. And we don't have a real great way of disposing of radioactive waste. Remember, we put them in these cooling tanks, and then our best solution right now is to essentially just take that nuclear waste and just, bury it underground. And that's not a real good solution. It's the equivalent of, your mom telling you to clean your room, and then you just take everything and just jam it under your bed. Eventually it's going to come back to bite you. Except, the clothes on your bed aren't going to give half the country cancer. But to go along with that, not only is this stuff radioactive, but it can also be transformed into a gas. So if it's heated, it can transform into radon gas, and then it's mobile in the air, and then it's highly transmittable, okay, because it's not refined to the ground, it's airborne, okay. So those are the problems with nuclear power. The main solution for nuclear power has been just to stop it, which is what most of the world has done. Some countries still use nuclear power. Japan used nuclear power up until 2011 with the infamous Fukushima accident, where a tsunami caused a core meltdown, which caused an explosion, which leaks God knows how much radiation into the ocean. The main solution for nuclear power is to just not use it anymore, which most of the country has done, because the benefits of nuclear power are not worth the consequences if and when it messes up, and it has messed up multiple times. Okay, so yeah, here we go. Remember we had this discussion. What do we do with the nuclear waste? We bury it. We shoot it to space. We bury it in Antarctica. Bury it on the ocean floor, right? These are the solutions we have for nuclear power. They're all terrible ideas, but that's what we have. Okay, so those are all of the non-renewable resources with their pros and cons. Let's talk about some renewable resources. And I'm only going to go into a couple. There's a ton that we could talk about. I'm only going to go into a couple, namely the first one being solar. Where is solar? Here we go. Solar power. Okay. Now, how solar power works is it uses what's called a PV cell. A PV cell. That's not what I wanted. PV cell. Okay. The PV stands for a photovoltaic cell. Okay. And essentially what this is it is a unit. I don't really know what the best way to describe it aside from a unit that can take light energy and bounce it between a couple panels and utilize those electrons to make electricity. It's almost similar to how plants do photosynthesis in a little bit of a different way, but it's the same basic idea. So what's nice about solar energy is that it's a renewable resource. It's limitless. We get our power from the sun. It has zero forms of pollution. It's an unlimited source. It's pretty cost effective. And it's not only good for electricity, but it can also be used for heat. And there have been tons of examples, like houses and buildings used to be built off of their ability to block and absorb sunlight. The reason why roofs are built the way they are is to block out the sun in the summer, because in the summer the sun is higher. So when the sun is higher, your roof is designed to block out that sunlight, which if it blocks the sunlight, that means the heat can't get into your house. That's why you have an overhang on your roof. But when the sun is lower in the winter, it can allow that sunlight into your windows. And if it can get in through your windows, that heat is then able to be retained in your house. So houses and buildings are built on the idea of what's called passive solar, where you're using not the energy of the sun to make electricity, but you're actually using the heat to either warm your house or you're blocking it to make your house cooler. Houses have been created like this for years, decades, centuries. Okay. So you can see here, the idea of the summer sun is to block it out to keep your house cool. When it's lower, it lets the sun in to make it warmer. Okay. So these are all the solutions. These are all the benefits, right? Solar is unlimited. So it's pollution free. It can be used for heating. It can be used for electricity. What are the problems? The problem is it's not very efficient, right? It's 10% efficient. That number is actually outdated. Nowadays, it's close to 20 to 25%, which is great, but it's still too low to be totally reliant on solar. Because the other problem with solar is that it's solar. Literally half of all time is not solar. So in order to make solar efficient, you have to have batteries that go with it, where you fill up the battery during the day so that at night, when there's no sun, you can still use electricity. So we need to have way more efficiency in order to make up for half of the time when the sun is not shining. So solar is a good idea. It just currently in its current state is not, the technology is not there for it to be the be all end all. We have to solve the efficiency problem because we have to be able to solve the night problem. And the better technology we have, the more it will affect cost, because it's currently not a costly. It's very expensive, which is why most people have it. And the way you fix most of that is, as a government, you invest in this sort of thing. And our government has never invested in renewable energy or solar power. The second one to go into is wind. Okay. So wind is using the wind to transfer kinetic energy into electrical, right? The wind spins a turbine, which creates electricity. Our benefits: it's pollution free. It's a good source. It's more efficient than solar is. The problem is it's reliant on wind. So you can only really use it in places that have a lot of wind. So we can see here, capturing about 20% of the wind energy capturing only 20% of the wind energy at the world's best energy sites could meet all the world's energy demands. So there's enough wind around to where we could spread it out and provide energy for everybody. The issue is, well, let's get into it. So wind power is the world's most promising energy source. And, what I would say is that the problem with wind and the problem with solar, you could combine the two. So what I mean by that is, if the problem with solar is that you can only do it during the day and you can't do it at night, and the problem with wind is that you can only do it in places with wind and it doesn't work where there's no wind, combine the two, right? Have solar, they don't have to meet exclusively all of your energy needs. You could have solar and wind, and together they can fill each other's holes, whereas it doesn't have to be one or the other, okay? So the main problem with wind is the same with solar. If you don't have it, it doesn't work. But if you use them in tandem, then that solves your problem. Okay. The other problem with wind is more of a physical one, right? Wind turbines can be used to individually produce electricity. But the main problem is that, these aren't small. These are fairly large monstrosities. So they produce a lot of noise, which is inconvenient for people. And more importantly, from an environmental standpoint, they're big and they're in the air. And so the one at UNT got a lot of bad pub because birds would hit them and it would kill birds, right? And they would used to be literal piles of birds underneath these things because they would hit them, because birds, if you don't know this, are stupid. And so one of the big cons is that they actually they kill birds. So one of the ways you could offset that is by essentially trying to put these in places that have low amounts of air traffic, namely the ocean. The shores are a really good place for wind turbines, because shores produce a lot of wind and they don't have a lot of air travel or air traffic. So that's wind power. The United States once led the world in wind power. Europe surpassed us because, again, the government didn't fund it. So a good solution for both solar and wind would be to get the government to fund it, to actually get the technology to make it better. The last one we'll go into is, let's do two more. Let's do geothermal. Geothermal is kind of cool because what geothermal is you're essentially using the heat from the Earth's core to heat up water. So you take water and you pump it underground, and as it farther down it goes, the more hotter it is, and you use that heat to then heat that water to bring it up to turn it into steam. There's a ton of places that this could work. Okay. The problem with geothermal is that it's not very effective. It's not very efficient. Okay. That's sort of the recurring theme with all these renewable resources. None of them are very efficient. And the way you make them more efficient is to invest in research and development to make them more efficient. But we haven't done that. The benefits: it's pollution free. Okay, it's everywhere. It's not limited like solar or wind is. It's very cost inefficient. It's very expensive to do, and the conversion is very low. Okay. And then the last one we'll talk about is water, which comes in the form of tidal or wave power, using either a tide, the way a dam works, right? You build a dam, you create a higher water amount on one side, and as it flows down, it spins a turbine. And then the waves is you basically use the tides and the waves to move this switch back and forth. And every time you move it, it creates electricity. Okay. Now, the benefits of both of these are that you're taking advantage of the natural flow of water, right? You're not essentially disrupting the flow of water, at least on the surface. You are just taking advantage of it. The problem is that you're putting something physical in water, right? So like with dams, you are segmenting ecosystems. You're putting a literal giant wall in between a river or a pond or something, and then you're putting a turbine there. So you are breaking an ecosystem in two. Same thing with these wave pools, right? Putting them in the wave is a physical barrier between this side of the water and this side of the water. So the way that you do this is that you can't just have it's not good enough to just create all these barriers. That's not good, because then you get a problem like you have with the Colorado River, where there's so many dams, it's restricting the amount of water that gets to the ocean. Or with here, if you just have bunch of these different wave power plants, there needs to be breaks to where fish are able to swim through easily, sort of like a bridge over a highway, so that wildlife can get from one side to the other. Wildlife need to be able to get from one side of the ocean to the other side. And then again, other problems is these are really expensive. They're not very efficient, and with both of these, you're limited to where there is water. So and that's really true with wind and with solar and with geothermal. So with all of those, another problem is you need to be able to transport the electricity from where you're getting it to where it needs to be. And that takes time and money and investment. And these systems are not set up to be mass systems yet. There's not enough. Imagine if there was like one cell phone tower in one town. Like, it works great in that town, but as soon as you go outside of that radio tower, like it becomes useless. We have to have these networks of cell towers in order for your phone to work everywhere. We need networks of wires and able to transport this electricity from these renewable resources to everywhere else to set them up. And we're just starting to get to that point where it's actually possible to do that. So yeah, that's it. That pretty much covers renewable resources and non-renewable resources. Again, be sure that when you're doing your studying, you're focusing on problems and solutions, because I feel like that's going to be what they ask you most about. If you have, I would highly recommend that you have a renewable resource in the back of your pocket and know the pros and the cons, so that if they ask you to compare and contrast, you can do that. And then definitely know the pros and the cons of the non-renewable resources. So yeah, I hope you enjoyed it. I'll see you next week.